Hi there, my name is Abbas and today with my colleague Haider Lefte, we shall present you a simplified explanation about the main rig systems. The contents of this presentation include modest answers about the following questions. What is a drilling rig? What are the main rig systems? The definition of each system. How does each system operate? The components of each system and their uses. If you search for a definition for drilling rigs, you will get multiple answers. But we can simply say that a drilling rig is a large structure with equipment for drilling an oil well. Drilling rigs have changed extensively since the first commercial oil well in Ticeville, Pennsylvania. It was drilled with a cable tool rig. Cable tool rigs, as shown in the figure, lift and lower a bit to pound a hole in rock formations, as needed. Pounding would be stopped so water and debris could be bailed from the hole with a bailer on a cable, and then the pounding resumed. Cable tool rigs could routinely drill from 25 feet per day to 60 feet per day. Cable tool drilling, which is also known as percussion drilling, was used for all U.S. fields in the 1800s. But this method is slow. It does not prevent unstable rock from collapsing into the wellbore and it does not effectively control subsurface pressure. Consequently, the uncontrolled production of fluids known as blowout was common.
Another drilling rig type which is the rotary drilling rig. Rotary drilling rig was introduced in the late 19th century and became the primary drilling method by the early 20th century. The size of the rotary rig depends on the weight and the power requirement associated with the depth of the well. A larger rig is used for a deeper well. Onshore rig can be either moved in pieces and assembled on location or mounted on a truck. Offshore rig come in different forms depending on the water depth. Barges can be used for shallow water or swamps. Jack up can be used in water that's relatively shallow to a few hundred feet of water. Semi-submersible are used in couple thousand feet of water. Drill ships are used in several thousand feet of water. Rotary drilling rig types. The land rig,
Drilling barges,
jack up rigs,
semi-submersible rigs, rotary rig systems. A modern rotary rig, as shown in the figure, consists of multiple systems. First is the hoisting system, second is the rotary system, third is the power system,
and fourth is the circulation system, and fifth is the well control system, which is the most important system.
first is the power system. The power system on a drilling rig provides the power for the other main systems on the rig, and other ancillary systems such as electrical systems, pumps, etc. The system typically consists of a prime mover, which is the component of the power system that generates the raw power, and a means to transmit the raw power to the end-use components on the rig. In this figure, we can see the drilling rig, and here is the power system. The power system typically consists of two main parts. The first is the fuel storage, which is item number 37, and the second is the engines and generators, which is item number 38.
The second system in the drilling rig is the hoisting system. The hoisting system is a large pulley system. The hoisting system is a system that used to raise and lower equipment into and out of the well. The hoisting system component. The first part of the hoisting system is the derrick. The derrick is a metallic structure which has four supporting legs resting on a square base. It's irrigated on substructure which supports the rig floor and the rotary table and provides workspace on the rig floor. We have two types of derrick. The standard derrick, it's, it is a vaulted constructor and assembled part by part. And the second type is a portable derrick, which is called mast, when capable of being irrigated as unit. The second part of the hoisting system is the drawwork. The drawwork is the control center from which the driller operates on the rig. It contains clutches, chains, and another controls, provides the hoisting and braking power to enable movement of load in and out of the hull. The drawwork is characterized by the brake system, which enables the driller to easily control a load of 1,000 of pounds of a drill pipe or casing. We have two types of a brake system: mechanical friction device, which can bring the load to complete stop. The other brake is hydraulic or electric, not capable of bringing it to complete stop. It can control the speed. An integral part of the drawwork is the transmission system. This gives the driller a wide choice of speed for hoisting the drill string. Drawworks has two catheads, is used to spin and tighten the drill pipe joint. The drum is housed in the drawworks and transmits the torque required for hoisting and braking. Another part of the hoisting system is a crown block. A crown block is a fixed set of pulleys at the top of the derrick of a drill rig over which the drilling line is threaded. The pulleys are assisted by the traveling blocks that together are capable of hoisting heavy loads. The deadline. The deadline is the drilling line strung through the traveling block and to the drawworks is secured by the deadline, which is wrapped around the deadline reel and clamped. This prevents the line from slipping and the traveling block from falling, and it's called the deadline because it does not move compared to the fast line. The traveling block. The traveling block is a pulley assembly that connects the drilling line to the hook and swivel. The block and tackle which is rigged with the crown block by multiples of drilling lines strung between the crown block and the traveling block. Another part of the hoisting system is the deadline anchor. The deadline anchor anchors the deadline to the rig floor. A weight indicator is attached to the anchor. A drilling line supply reel. A drilling line supply reel, a reel with a spare drilling line, which is attached to the deadline and the anchor. The drilling lines. The drilling lines, a wire rope or steel cable, used in the hoisting system, are used to hoist or lower the drill pipe into and out of the wellbore. The hook. The hook is located beneath the traveling block. This device is used to pick up and secure the swivel and kelly and pick up heavy loads with the traveling block.
The next rig system is the rotary system. Rotary drilling is used to form a deep observation borehole or for obtaining representative samples of rock. It is also used to rotate the drill string and therefore the drill bit on the bottom of the borehole. This system requires lubrication like air, water, or drilling mud to keep the cutting head cool. This system includes the following major parts. Swivel. Swivel is positioned at the top of the drill string. It has three major functions. It supports the weight of the drill string, permits the string to rotate, and allows mud to be pumped while the string is rotating. Next part of the rotary system is the Kelly. A Kelly is the first section of pipe below the swivel. It is normally about 40 feet long and has an outer hexagonal cross section. It must have this hexagonal or sometimes square shape to transmit rotation from the rotary table to the drill string. The next part is the Kelly bushing. The Kelly bushing has 4 pins, which fit into the post holes of the rotary table. When power is supplied to the rotary table, torque is transmitted from the rotating table to the Kelly via the Kelly bushing. Rotary table. Rotary table is located on the drill floor and can be turned in both clockwise and anti-clockwise directions. It is controlled from the driller's console. This rotating table has a square recess and 4 post holes. Next is a drill string. Drill string on a drilling rig is a column or string of drill pipe that transmits drilling fluid and torque to the drill bit. Next part, which is mainly found in the modern rigs, is the top drive. The top drive is basically a combined rotary table and a Kelly. Next, next is drill bit. Drill bit is used to cut or crush rock. With rotary drilling, a hole is drilled by the continuous turning of a drill bit. There's 2 types of drill bits: fixed cutter bits and rolling cutter bits. Drilling collar. Drilling collar provide weight and stability to the drill bit. It maintains tension on the drill pipe and help keep the hole on a straight course.
Another drilling rig system, which is the circulation system. The circulation system is a continuous system of pumps, distribution lines, storage tanks, storage beds, and a cleansing unit that allows the drilling fluid to fulfill its primary object. As you can see in the figure, here's a drilling rig, and all the items shown in the figure belongs to the circulation system. The circulation system component is the mud pumps. The mud pumps is the heart of the circulation system, used to circulate the drilling fluid from the mud pits through the drill string down to the bit and return up to the surface through the animals. There are 2 types of mud pumps, duplex and triplex. The double-acting duplex pump has 4 pumping action per pump cycle. The single-acting triplex pump has 3 pumping action per pump cycle. The next component is the mud house, the place where the mud additives are kept at the rig, also known as the sack room. Next, waste pit. Waste pit, reserve pit, is an earthen pit excavated adjacent to a drilling rig, and it's commonly used for the disposal of a drilling mud and fluids in natural gas or oil fields. The next component is the mud pits. The mud pits are a series of large interconnected steel tanks, fitted with agitators to keep solid in suspension. There are some pits are used for the circulation and other used for mixing and storing drilling mud. Freshwater and base oil, which are used for making drilling fluids, are pumped from the storage tanks. The next component of the circulation system is the shell shaker. The shell shaker are a component of a drilling equipment used in many industries such as coil cleaning, mining, oil and gas drilling. They are the first phase of a solid control system on a drilling rig and are used to remove large solids from the drilling. Once the drilling fluid has completed one cycle from the mud pit and up to the surface, it will contain solid, some gas, and these non-drilling fluids, product, or contaminants must be removed in order to keep the required properties needed to drill safely. After returning to the surface of the well, they used drilling fluid flows directly to the shell shaker, where it begins to be processed. Once processed by the shell shakers, the drilling fluid is deposited into the mud tanks, where the other solid control equipment begins to remove the finer solids from it. Another component of the circulation system is the mud gas separator. The mud gas separator is commonly called the gas buster or bore boy degasser. The mud gas separator is used to capture and separate the large volume of a free gas within the drilling fluid. Choke manifold. Choke manifold is a set of high pressure valves and at least two chokes associated piping used to lower the pressure from the well head. These chokes can be fixed or adjustable or mix of both. Choke manifold is typically located on the rig floor and provides a flexible and variable flow control and well shut-in capability. The next component is the degasser. The degasser, a device that removes air or gases like methane, H2S, CO2, and other gases from the drilling liquid. There are two generic types that work by both expanding the size of the gas bubble entered in the mud or by increasing the surface area available to the mud so that gas bubble escapes. If the gas content in the mud is high, a mud gas separator or bore boy degasser is used because it has higher capacity than the standard degasser and routes the evolved gas away from the rig to an flaring area complete with an ignition source. Another component of the circulation system is the descender. The descender is a hydrocyclone device that removes sand-sized particles and larger drilled solids from the whole mud system. One of the primary applications is to improve the quality of the wastewater. The descender should be located downstream of the shell shaker and before the degasser and the desalter and other mud cleaners. Another component of the circulation system is the desalter. The desalter is a centrifugal device for removing very fine particles or silt from the drilling fluid to keep the amount of solid in the fluid at lowest possible point. The desalter is located downstream from the descender and the surface of the mud system. As with the descender, its purpose to remove unwanted solids from the whole mud system. The rotary hose. The rotary hose a large diameter, 3 to 5 inch inside diameter, high pressure flexible line used to connect the standpipe to the swivel. This flexible piping arrangement permits the killie and in turn the drill string and pit to be raised or lowered while drilling fluid is pumped through the drill string.
The last system of the main rig systems is the most important system, which is the well control system. The well control system, as shown in the figure, or sometimes it is called the blowout prevention system, is the system that prevents the uncontrolled catastrophic release of high pressure fluids, such as oil, gas, or salt water, from subsurface formations. These uncontrolled releases of formation fluids are referred to as blowouts. Due to the explosive nature of oil and gas, any spark on the surface can result in the ignition of the fluids and an explosion on the rig. An explosive blowout and the failure of the well control system were the causes of the Mokondo well disaster. that killed 11 of the rig crew on the Deepwater Horizon on April 2010 and resulted in 35,000 to 60,000 barrels per day of crude oil to spill into the Gulf of Mexico. A blowout begins as a kick entry of subsurface formation fluids into the wellbore. What distinguishes a kick from a blowout is that a kick can be controlled, while a blowout is uncontrollable. Now, the well control system consists of three major parts. The first part is the accumulator. The accumulators are used to store pressurized non-explosive gas and pressurized hydraulic fluid to run the hydraulics systems on the rig. The accumulators store enough compressed energy to operate the blowout preventers even if the power system of the rig is not operating. The second part is the blowout preventer. The blowout preventer (BOP) is a large system of valves, each of which is capable of isolating the subsurface of the well from the rig to provide control over the well. These valves are typically stacked as shown in the figure and sit below the rig floor on land wells or some offshore wells, or they may sit on the seabed on other offshore wells. The last part of the well control system is the annual preventer or the annular preventer. This part of POP seals and closes the well by a circular piece of rubber. It can close on any pipe and casing sizes, and it closes the open hole. Choke line. Choke line. This line allows the circulation of the influx to choke manifold. It has two main valves, hydraulic and manual. The manual valve is used as a safety valve in case of hydraulic valve failing. At last, this is a simple video that shows a kick. Remember, as we have mentioned, a kick is controllable, while a blowout is uncontrollable. Here's the crew of engineers trying to control the kick.
And that was a brief description and a simple explanation of the main rig system and how does each system work and the component of each system. At the end, I hope you enjoyed our presentation. Thank you for your attention.